After self-reading the first part, now let me discuss the second part with you. Over here, you have the summation of r equals to n plus 1 to 2n of r plus n. Okay, the whole purpose of this question is to unpack the sigma notation and to link it to an AP. So if we look at this, okay, now we got to take note which variable is which one is a variable and which one is the constant. So you notice that this is a sum of r from n plus 1 to 2n. So this n here is taken as a constant. Okay, it's a fixed constant. You have to first recognize that. Now, when you can't see or you don't know how to begin, okay, it will be useful if you can write down the first few terms. Usually we write down the first 3 terms and the last term of the summation. So the first term will be when I substitute in r equals to n plus 1. That will give me n plus 1 plus n. The next term will be I sub in n plus 2. That will give me n plus 2 plus n. And the following term will be n plus 3 plus n. So on and so forth until the last term where I sub in 2n, r equals to 2n, and I obtain 2n plus n. So by rewriting the terms within each bracket, you see sometimes we don't expand all the way out. We just look at within each bracket, it is 2n plus 1, 2n plus 2, 2n plus 3, 2n all the way up to 2n plus 1 plus n. So if you look a bit more closely, you'll realize that all these terms are in an AP, right? So the common difference is 1. The first term is 2n plus 1. Now the question is, how many terms are there? So the number of terms we can obtain from this sigma notation, 2n minus n plus 1 plus 1 terms. So now we have all the necessary information. We have the first term, the common difference, the number of terms. We can apply Sn equals to n over 2, 2a plus n minus 1d. Now, do take note and don't confuse yourself. The n here refers to the number of terms. Okay, the total number of terms in the summation, in the series. So substitute in the values into this formula. You will obtain n over 2, 5n plus 1.